Do you know what a combustion engine is? We're here to explain exactly what they are. As the name suggests, a combustion engine is powered by a combustion mechanism. This is the most common form of combustion engine. In fact, they're at the heart of many vehicles, boats, planes, and even trains. You're probably wondering what goes on inside the engine. And well, so are we. But we'd like to remind you that it's all about the fuel. Inside the engine, the mixture of air and gasoline generates an increase in heat, which in turn creates the pressure needed to start the engine. This same mixture is then emitted in the form of exhaust gases. We're talking about a mechanism that's activated by a piston or a turbine. Now that you've grasped the simplified definition of a combustion engine, let's take a look at how Omega 1 could revolutionize the automotive industry. First of all, let's take a look at the history of combustion engines. Where do they really come from? Let's discover their origins. After all, they're still part of our everyday lives. So it's important to know a little more about them. In 1860, Dutch physicist Christian Huygens drew what appears to be an internal combustion engine. Around 1775, the Swiss François Isaac de Vaz foresaw the possibility of developing the automobile. He produced a large number of steam-powered carriages, but they weren't as successful as he'd hoped. They were far still too inflexible to appeal to potential buyers. On January 30th, 1807, he obtained a patent for an engine that vaguely resembled a combustion engine. Subsequently, the Italians Eugenio Bersanti and Felice Mattiucci presented an engine worthy of the name. This was powered by a mixture of air and gas. Little by little, we began to look at a glimpse of the combustion engine as we know it today. It was Belgian engineer Etienne Lenoir who marked a turning point in the history of combustion engine design. In 1859, he patented a gas engine with expanded air. This was a two-stroke internal combustion engine. A year later, he developed the first draft of real combustion engines. At first, it was powered by lighting gas, but this did not last long. It was soon replaced by petroleum thanks to the invention of a carburetor. Unfortunately, his research was soon aborted for lack of funds. What's more, the carburetor's performance was not always up to scratch. Baudot Rachat took matters into his own hands, developing a four-stroke thermodynamic cycle. Despite a few setbacks, this man's knowledge enabled the combustion engine to be pushed to its limits. However, it was not until American George Brayton arrived on the scene. He designed a highly efficient carburetor that ran on petroleum. The result was the first heavy oil internal combustion engine. In 1807, the Niepce brothers introduced the world to what we now call the diesel engine. At the time, it was a pyrolyphore, a dilated air engine. The Frenchman Fernand Forest developed the float-type constant-level carburetor. For more than 70 years, all carburetors were manufactured using this principle. In general, Forest revolutionized the history of the automobile, notably with the invention of the four-cylinder vertical engine with controlled valves. In 1876, German engineer Gottlieb Daimler developed the first gas-powered stationary engine. As for the first four-stroke engine, it was installed in a four-seater car by René Panhard and Émile Levasseur in 1889. Do we really know what the first car in history was? It's hard to say. Yet, many agree that it was the Benz patent motor wagon, produced by Carl Benz. How will these engines evolve? Now that this little history lesson is over, let's take a look at how a combustion engine works. What do you think? There are three types. The spark ignition engine is a gasoline engine. It uses a spark plug to ignite a combustible mixture. This is not supposed to happen spontaneously. As a result, it generates two-stroke or four-stroke reciprocating movements. More rarely, we speak of rotary motion. The diesel engine houses a fuel injection system at the heart of the combustion chamber. With a high compression ratio, this raises temperatures to very high levels. This is known as self-ignition. Finally, the gas engine, as its name suggests, uses gas as fuel. First conceived in the 19th century, it was thanks to Kyoto Protocol in 1997 that it was seen as a product of the future. This protocol aims to reduce CO2 emissions. It's high time we got to grips with the principle of the four-stroke combustion engine. Indeed, this is the most commonly used engine. In the first stage, the mixture of air and fuel ignites and drives the movement of the piston. As it descends, it draws into the cylinder. The mixture is compressed and the intake valve closes. The piston moves back up to compress the mixture inside the combustion chamber. It is at this precise moment that the piston reaches its maximum point. The hot gases exert a strong pressure on the piston. This is how the movement is initiated. The exhaust valves open. The piston rises and expels the burnt gases into the exhaust manifold. The cycle then begins its slow progression again. Today we're talking about the Omega 1 engine. Is it a revolutionary invention? The Omega 1 engine was developed by engineer Matthew Riley at Aston Aerospace. According to the company, it's set to change the world of combustion engines for good. How's this possible? First of all, Omega 1 is much smaller but much more powerful. And not least, it consumes far less fuel than its competitors. Will the promise of unrivaled efficiency be kept? It looks like the future of combustion engines. Its pollutant emissions are extremely low, and its power-to-weight ratio is outstanding. What's more, unlike piston engines, they have very few losses. What's more, Omega 1's compressor is far superior to all others. In fact, it's an integral part of the combustion process. Generally speaking, an engine of this type is much more efficient overall, for a reason we'll explain right away. For example, when a vehicle is accelerating, the engine can pull with every revolution, but when it reaches cruising speed, it only fires when needed. In this way, it idles at high speeds but consumes very little fuel. If power is required again, it's almost instantaneous. The Omega 1 motor is also the first active linear power transfer motor. When running, power is transferred via the unique rotating power shaft. With the rise of electric cars, is it possible to save combustion engines? It may seem an ambitious prospect, but Aston Aerospace is not about to give up. There's no doubt that the performance of electric vehicles rivals that of conventional ones. The market is therefore in good shape. As a result, internal combustion engines are likely to disappear in the years to come. We don't yet know how, but it's high time things started moving in the direction of our planet. We're well aware that it will be very difficult to eliminate all internal combustion engine cars in the near future. That's exactly why Aston Aerospace has decided to bet on a revival of the internal combustion engine. It should produce little or no harmful emissions. The fact that Omega 1 has two chambers, one for the cold air and the other for the hot exhaust gases, means that the damage in terms of emissions is greatly limited. Is Omega 1 a viable and above all sustainable project? Can the promises made really be kept? Are we on the verge of a genuine automotive revolution? Will we manage to think more about our planet than our own comfort? Will individualistic thinking cease to be central to our evolution? Don't hesitate to give us your opinion on the subject by leaving us a comment below. We look forward to hearing from you. See you soon on aTech.